Welcome to AI TechBook. This is the Atlas. Episode 6, Context Engineering and Reliability. Two true stories. First, a coding agent runs for an hour, doing real work. Then it hits its context limit and starts rereading files it already understood 20 minutes ago. It lost the thread. It forgot. Second, a tool use agent calls web search at 2 in the morning. The server-side loop hits its limit, hands back a stop reason called pause turn, and the code treats it as finished. The agent stops mid-task. Nobody notices until morning. Episode 5 taught how to compose one request, the prompt, the schema, the contract, but almost nothing you ship is one request. It is a conversation that runs for an hour. It is an agent loop that fires 40 tools. And the moment the run gets long, two new problems appear. Context, what the conversation carries forward and what it quietly drops. Reliability, what keeps the whole thing running when a call overloads, a loop stalls, or the model makes something up. Here is the framing. Context is the model's working memory. It is finite. And Anthropic's own word, it rots. As token count grows, accuracy and recall degrade. More context is not automatically better. Two problems. Two deep dives. One thread through every scene. The long run is the real test. Before any technique, one fact has to land because every context decision follows from it. The context window is not storage. It is working memory. And working memory has a cost that storage does not. The more you put in, the worse the recall gets. Anthropic defines the context window as all the text the model can reference when generating a response, including the response itself, a working memory for the model. As a conversation advances, every user message and every assistant reply accumulates inside it. Previous turns are preserved completely and losslessly by default. The frontier tier, the latest Opus and Sonnet models, carries a 1 million token window. Most other models carry 200,000. That sounds like room to spare. It isn't. Here is why. Quote verbatim from the Anthropic docs, as token count grows, accuracy and recall degrade, a phenomenon known as context rot. This makes curating what's in context just as important as how much space is available. The vendor that sells you a 1 million token window is the same vendor telling you that filling it makes the model worse. The window is the budget. Context rot is the interest you pay for overspending it. This is the trap behind the agent that forgot. It did not run out of space. It drowned. The signal it needed was buried under 40 tool results it no longer needed, and recall degraded until it reread files it already understood. The fix was never a bigger window. The fix is curation. If you're an architect, this reframes the whole design. Stop asking, will it fit? Start asking, what is the smallest high signal set that does the job? The token counting endpoint lets you measure context before you send it. Treat the window like a budget you manage, not a bucket you fill. Anthropic frames context engineering as the natural progression of prompt engineering. Prompt engineering was about writing the instruction. Context engineering is about curating and maintaining the optimal set of tokens during inference across the whole run, not just the first turn. The central constraint is one sentence: find the smallest possible set of high signal tokens that maximize the likelihood of some desired outcome. Everything else is application of that one rule. The first technique is just-in-time retrieval. Rather than loading all relevant information up front, the agent stores what it learns and pulls it back on demand. The active context stays focused on what is currently relevant, lightweight identifiers in the window, the full content fetched only when needed. For long horizon work, Anthropic names 3 techniques, and you will recognize all 3 by the end of this episode. 1. Compaction. Summarize the conversation history and reinitialize with the condensed version. 2. Structured note-taking. The agent maintains persistent external memory, a notes file it writes to and reads back. 3. Sub-agent architectures. Specialized agents handle focused tasks and return only distilled summaries to a coordinator. Compaction and note-taking are this episode's deep dives. Sub-agents are the next episode. Notice what all 3 have in common. None of them make the window bigger. All of them decide what leaves the window. Context engineering is subtraction discipline. The skill is not adding the right tokens. It is removing the wrong ones before they rot the rest. If you're a developer, the model shift is concrete. Your system prompt should hit the Goldilocks zone, specific enough to guide behavior, flexible enough to leave room for judgment. And the heavy reference material does not belong in the prompt at all. It belongs behind a retrieval tool The agent calls when it needs it. The agent that forgot had nowhere to put what it learned. The memory tool is that somewhere. It is the single primitive that most directly embodies the whole doctrine, and it is generally available today, no beta header required. Quote, verbatim, the memory tool enables Claude to store and retrieve information across conversations through a memory file directory. The model can create, read, update, and delete files that persist between sessions, allowing it to build knowledge over time without keeping everything in the context window. Read the second half of that sentence again without keeping everything in the context window. That is the whole point. Memory is how you take the heavy state out of working memory and still get it back when you need it. Here is the moment that matters, and watch the screen. The context window gets wiped, a reset, a new session, the window starts empty. But the memories directory survives, because it lives in your infrastructure, not in the window. The agent that forgot, with memory enabled, now opens its memory directory, reads its own progress notes, and recovers full state, in seconds, without re-exploring everything from scratch. The forgetting problem does not get a bigger window. It gets a memory, and the model is trained to use it defensively. When the memory tool is enabled, Anthropic Auto injects a system instruction. Quote, always view your memory directory before doing anything else. Plus an assume interruption protocol, your context window might be reset at any moment, so you risk losing any progress that is not recorded in your memory directory. The model is told, upfront, to treat its own context as disposable and its memory directory as the source of truth. If you're an architect, here is the critical design fact. The memory tool runs client-side. Quote, you control where and how the data is stored through your own infrastructure. The model emits tool calls, view, create, story, replace, and your application executes them, scoped to the memories directory. You own the security boundary. Validate every path starts with the memories directory. Reject ... traversal and its encoded forms. The model proposes. Your code disposes. The anatomy was the idea. This is the wiring. Two things to get exactly right: the tool block in the request and the loop your client runs to execute the model's memory commands. The tool block is deliberately small. Type, memory 2, 02, 508, 18. That date stamp is the version, and it is load-bearing. It is not a generic memory type. It is that exact string. Name, memory. That's the whole declaration. Because the tool runs client-side, there is no schema for arguments in your request. The model knows the 6 commands, and your client implements each one against the memories directory. Enable the tool, and the model starts managing its own memory files. Now the multi-session pattern, which is where the long run is won. An initializer session sets up the memory artifacts, a progress log, a feature checklist, before any work begins. Every new session opens by reading them, recovering full state in seconds without needing to re-explore the codebase. Before a session ends, it updates the progress log. The context window resets between every session. The memory directory does not. 3 sessions, 1 continuous thread of work, 0 re-exploration. That is the agent that forgot fixed, and the pairing that makes it bulletproof. Memory composes with compaction, the next scene's topic. Quote, compaction keeps the active context manageable without client-side bookkeeping, and memory persists important information across compaction boundaries so that nothing critical is lost in the summary. Compaction shrinks the conversation. Memory makes sure the things that matter survive the shrink. You use both. If you're a developer, the build checklist is short and the security half is non-negotiable. 1, add the tool block. 2, implement the 6 commands against a real directory. 3, and this is the one people skip, validate every path. Resolve to canonical form. Reject ... Reject the encoded sequences. The model is writing files on your infrastructure. Treat the path like untrusted input, because it is. Halfway, you have the context half, working memory, the rot problem, the memory tool, and next, compaction. The second half flips from what the conversation carries to what keeps it running. If the context half already changed how you think about the window, the channel runs one of these every week. The link is below. Subscribe to AI TechBook. Memory takes state out of the window, but the conversation itself still grows. Every turn, every tool result, piling up toward the limit. 2 server-side tools manage that growth. One summarizes. One clears. They are not the same, and using the wrong one costs you. First, compaction. Anthropic's recommended primary strategy for long-running conversations. Quote, server-side summarization that automatically condenses earlier parts of a conversation, enabling long-running conversations beyond context limits with minimal integration work. You set it in the context management parameter, edits array, type compact202. 601. 12 behind the compaction beta header. By default, it fires when input crosses 150,000 tokens. The API summarizes the old turns, emits a compaction content block, and continues. And it automatically drops the message blocks before that summary. Note the staleness catch, it is not a top-level compaction true flag. It is a typed edit in the context management parameter. Now context editing, the scalpel, for when you need fine control instead of a summary. 2 strategies. Tool result clearing removes the oldest tool results once context passes a threshold, default 100,000 tokens, keeping the last 3 tool uses, and replaces each cleared result with a placeholder so the model knows it was removed. Thinking block clearing does the same for extended thinking blocks. The contrast that matters, compaction condenses everything older into a summary. Context editing surgically removes specific blocks and leaves the rest untouched. Summary versus scalpel. And the detail that separates people who read the docs from people who get surprised in production. Both strategies happen server-side, and your client keeps the full, unmodified history. You do not sync your state to the edited version, but clearing interacts with your cache. Tool result clearing invalidates the cache prefix when it fires, so there is a minimum clear setting to make the invalidation worth it. Fire the scalpel too often on too little, and you pay to rebuild the cache every time. If you're an architect, the decision rule is clean. Reach for compaction first. Recommended default. Minimal integration, good for most long conversations. Reach for context editing when you need to protect specific tool results from being summarized away, or clear noisy ones precisely. And pair either with the memory tool, so the things that must survive the shrink are written down before the shrink happens. Every successful response from the messages API carries a field called stop reason why the model stopped. Not an error. A normal field on a 200 response. And here is the uncomfortable part. Most production tool loops only handle 2 of its values. The other 5 are where agents silently break. Stop reason tells you why generation stopped, and it is distinct from errors, which come back as HTTP 4XX or 5XX. There are 7 values. End turn, the model finished naturally. Max tokens, the response hit the token limit and was truncated. Stop sequence, it hit one of your stop strings. Tool use, the model is calling a tool and expects you to execute it. Pause turn, the server-side loop hit its iteration limit. Refusal, the model declined on safety grounds. And model context window exceeded, generation ran into the window ceiling. 7 outcomes. A reliable loop has a branch for every one. Here is the loop the 7 values demand. While true, call the messages API. If stop reason is tool use, execute the tool, append the result, loop again. If it is max tokens, and the last block is an incomplete tool call, retrieve with a higher limit to get the full call. If it is pause turn, send the response back as is to continue. If it is refusal, handle it gracefully. Do not retrieve blindly. Otherwise, end turn, you're done. That single branch structure is the difference between an agent that runs for an hour and an agent that stops at the first value you forgot to handle. And the 2 values that cause the most silent damage because they look like success. Pause turn is returned when a server tool like web search hits its iteration limit, by default 10 iterations per request. The naive code sees a normal response and thinks the agent finished. It didn't, it paused, and it is waiting for you to send it back. That is the loop that hung at 2 a.m. The second is the empty end turn. The model returns end turn with almost no content, usually right after tool results. It looks done. It isn't. If you're a developer, audit your loop right now against this list. If you handle tool use and end turn and nothing else, you have a 5-branch hole. The agent works in the demo because the demo never triggers pause turn or max tokens. Production triggers all of them. The long run is the real test. And the test is whether your loop handles every way the model can stop. This is the scene the whole reliability half was built for. The pause turn hang is not a rare edge case. It fires every time a server tool like web search or web fetch runs long. If your loop does not handle it, your agent stops mid-task and reports success. Let's watch it break, then fix it. Watch the naive loop first. While true, call the API. If stop reason is tool use, run the tool and continue. Else, return the result. That else is the bug. When pause turn comes back, it is not tool use. So the code falls into else and returns a half-finished answer as if it were done. The fix is one branch. If stop reason is pause turn, append the response and call the API again with no changes. Quote, continue the conversation by sending the response back as is. The server picks up exactly where it paused. One branch turns a silent hang into a completed run. Now the second hole, the empty end turn. Sometimes the model returns end turn with 2 or 3 tokens and no real content, right after tool results. Your loop sees end turn, declares victory, and ships an empty answer. The cause is subtle and worth knowing. Quote, adding text blocks immediately after tool results teaches Claude to expect user input after every tool use. The fix, send the tool result directly, with no trailing text block after it. And as a last resort, if it still happens, add a fresh user message that says simply, please continue. And the third branch people get wrong, max tokens. If the response is truncated and the last block is an incomplete tool use, you cannot just continue. You retried the same call with a higher max tokens to get the complete tool call. Because half a tool call is unusable. There is no rate limit downside to a higher limit. Either max tokens does not factor into the output token per minute calculation. Set it generously. Read which stop reason actually fired. Branch on it. If you're a developer, here is the whole reliable loop in one breath. Tool use, execute, and continue. Pause turn, resend as is. Max tokens with a partial tool call, retree higher. Refusal, handle, don't retree. End turn, done, but check it isn't empty. 5 branches. That is the entire difference between the agent that hung at 2 a.m. and the agent that finished the job while you slept. Your loop is bulletproof now. But on launch day, a traffic spike hits and the failures come from outside your code, from the API pushing back. Quote, 529 errors can occur when APIs experience high traffic across all users. If your app has no backoff, every one of those becomes a user staring at a failure. Know the error map, because the right response depends on which one fired. 529 is overloaded error. The API is temporarily overloaded. Retry with backoff. 429 is rate limit error. You exceeded a limit, and it comes with a try after header telling you exactly how long to wait. 400 is a bad request. Do not retry. Fix the request. 401, authentication. 413, request too large. Every error response also carries a request ID. Capture it, because it is the first thing support will ask for. Now the part that surprises teams. If your organization's usage spikes sharply, you can get 429S from acceleration limits. Not because you crossed your steady state limit, but because you ramped too fast. Quote, ramp up your traffic gradually and maintain consistent usage patterns. The fix for the launch day storm is not just retry logic. It is warming up, increasing load smoothly instead of slamming the API the moment the feature goes live. Backoff handles the spikes you can't predict. Gradual ramp prevents the ones you cause, and the rate limit headers turn guesswork into arithmetic. Every response tells you your requests remaining, your input tokens remaining, your output tokens remaining, and the reset timestamps. You do not have to guess how close you are to the edge. Read the headers and throttle before you hit the wall. For requests that run long, especially over 10 minutes, use streaming or the message batches API, so a single slow call doesn't time out. If you're a tech PM, this is the launch readiness checklist in 4 lines. 1. Exponential backoff on 529 and 429. 2. Honor the retry after header. Don't invent your own delay. 3. Warm up traffic gradually before launch. Don't spike. 4. Log the request ID on every failure. A team that ships those 4 does not have a 529 storm. It has a busy day. 2 more questions the long run forces, and a hard truth most demos hide. Question 1. When the model answers from a document, can you prove where the answer came from? Question 2. When you change a prompt, how do you know it got better? And the truth. Even at the same settings, the model does not give identical answers twice. First, citations, the audit trail. Set citations enabled true on a document block, and the model grounds its answer in that document, returning the exact cited text and its location, character index for text, page number for PDFs. Quote, significantly more likely to cite the most relevant quotes than purely prompt-based approaches, and the cited text is free. It does not count toward output tokens. The PM whose legal team asked where did that answer come from now has a source trail in the response itself. One critical boundary, citations cannot be combined with structured outputs from episode 5. Enable both and you get a 400. Pick one. Second, evils. How you know a change helped. The team that shipped on Vibes could not tell if a prompt edit made things better or worse, because they never built a test set. Anthropic's doctrine is 3 lines. Make success criteria specific and measurable. Not good performance, but an F1 of 0.85 on a held-out set. Prioritize volume over perfection. More cases with automated grading beats a handful of hand-graded ones. And grade with code first, and LLM judge second, humans only when you must. Test-driven development applied to prompts. And the guardrails for the question, did the model make that up? 3 techniques, all verbatim Anthropic. 1. Explicitly give the model permission to say, I don't know. It drastically reduces false information. 2. For long documents, ask it to pull word-for-word quotes first, then answer. 3. Best of N, run the same prompt several times and compare. Inconsistency across runs is a hallucination signal. The honest caveat also these reduce hallucinations. They don't eliminate them. Always validate high-stakes answers. And the determinism truth, the default temperature is 1, not 0. And even if you drop it, identical inputs do not guarantee identical outputs. That is precisely why best of N works as a check. If you're an architect, design for variation. Build evils that measure behavior in aggregate, not exact string matches that break on the first reworded sentence. 2 halves, 1 system. Context decides what the conversation carries. Reliability keeps it running. But what you do with that depends on which seat you're in. If you're an architect, your job is the long-run design. Decide the context strategy before you write code, memory for what must persist, compaction is the default shrink, context editing for the surgical cases. Then design for failure, back off, gradual ramp, and audit trail. You are not designing the happy path. You are designing what happens at hour 2, at the traffic spike, at the ambiguous answer. If you're a developer, your job is the loop and the wiring. Add the memory tool block and implement its 6 commands with path validation non-negotiable. Write the loop that branches on every stop reason, not just 2. Honor retry after. The checklist is short, and every item on it is something the demo let you skip and production will not. If you're a tech PM, your job is knowing it's ready. Reliability is not a feeling, it is evils that prove a change helped, citations that give legal a source trail, and a launch checklist that survives the spike. You ship when the test set passes, and the failure modes have owners, not when the demo looked good in the meeting. All 3 roles share one discipline. The demo is one request. The product is the long run. Context engineering and reliability are simply the 2 names for everything that only matters once the run gets long. 5 ideas. If you keep these, you have the episode. 1. Context is working memory, and it rots. More tokens is not more performance. Curate the smallest high signal set. 2. The memory tool persists state across the context reset, client side, in a directory you control. It is how the agent stops forgetting. 3. Compaction summarizes the old conversation. Context editing surgically clears specific blocks, summary versus scalpel, and both pair with memory. 4. A reliable loop branches on every stop reason, not 2. Pause turn and the empty end turn are the silent hangs. Handle them or the agent stops at 2 a.m. and tells you it finished. 5. Trust is built, not assumed. Citations for the source trail, evils for knowing a change helped, the I don't know guardrail, and the honest truth that outputs vary even at the same settings. Prompts compose the model. Context composes the conversation. Reliability is what you build on top. Build for the long run. Context is what the conversation carries. Reliability is what keeps it running. Together, they are the difference between a demo and a product. Thank you for watching. Share it with one person. Subscribe to AI TechBook for episode 7, Multi-Agent Systems and Orchestration. One agent survives the long run. Many agents need a conductor. The demo works once. Production is the long run, and now you know how to survive it.